Oh, I see. I hit. Okay. Um, I don't know what happened, but somehow it paused the recording. Um, okay, so maybe that was when I started to rant. I don't know. Um, so important is there are several um, reasons to embrace emergence theory. Most of those are really hopeful. Most of them are emotional, not really scientific, and that's what bothered me about it. Um, I mean, everything about emergence theory comforts me to tell me I'm doing the right thing, and I don't have to change my mind. I don't have to think any differently. I can keep eating meat. I can um, not worry about flies in my sink. It says I can build small, useful devices, and if I can find the right style of neuron, if it's back propagation, it will eventually emerge into something great. It also told Doug Lynott that if he had all the right rules, eventually, once he got to the critical number of rules, it would um, emerge into a conscious version of psych. It tells people, like, if we could just build the right virtual world with the right number of lessons that were diverse enough that it would actually see a method of experimentation and learning that it would do. But interestingly, is if we robotically force something to do these experiments, and then we had the neural network watch and train uh, by watching this experimentation, when we took the experimenting code away, the neural network would continue to do experiments because it would say it was patterning and doing what it, you know, trying to replicate what it just uh, witnessed. So in other words, first thing I want to do, I mean, first thing we should do or could do is have a neural network that would simply watch a set of robotic movements and see if it could sort of self-program to do those things. So for example, this is kind of what a large language model does is it looks at some text flying by. Eventually, when that text stops flying by, it can show us what it would look like if it started flying by again. Like it says, it's able to predict what the next would be. And so let's say we do this with action, a set of actions. We should be able to have those actions suddenly keep going instead of letters. We're doing actions. Um, also, and then if we can keep those actions from a list of intelligent, like motor operations, that would work too. So in other words, what we would do is we could put this around someone playing a video game, not necessarily Donkey Kong, but well, yeah, I mean, actually, it works with Donkey Kong too, or with Pac-Man. You can sort of watch, even though you can't see what the player sees, you can see what motions they decide to choose. If there's only 4 of them, right, or 5, hold still. That's not quite enough information, so we have to give board information and stuff. And anyway, we can make these, I think we can make these really killer game playing things, and they require a certain number of neurons, and if we get below those neuron thresholds, then it stops working. And so you get above 1, it starts working again. So there's this idea of a minimum that's going to take to pretty much do almost any action. Um, so let's say, go to something more intelligent, like learning. Um, oh, well, okay. Let's go to. There's two tangents here. We need to follow both. So one is that having. So the one tangent that we're not going to follow right the second is that um, that learning itself is a set of actions that lead to another set of actions that get things get filled in, and that's what learning is. Okay, so you don't just experiment uh, randomly. Your experimental system could actually be pre-programmed in to do some of these experiments, and then by non-pre-programming, you could learn to do more. Okay, so that was part one, tangent one. So the other one is that, see if I can remember, because I actually secretly can't right this second. It was, no, I can. Let's see if I can scroll up and get what it was. Oh, okay. That with the right number of lessons and the right size of the view of the world, we have to have a minimal amount of free of context. And that the idea of context, and this is not necessarily part of emergence theory. This is actually part of my theory, is that the amount of context is so verbose and strong in the human mind that there's very little thinking going on. And that's not enough information really to explain what I'm saying. I was trying to say that, okay, if it, I feel like this needs to be talked about in deeper later, because first thing I'm going to try to do is just give an overview of how I'm going to try to argue. So I'm going to talk about what emergence theory is. Then talk about how it relies on, so it's sort of a critical mass idea, but that's a more mature version of critical mass. So it's a way of trying to, at least the way even Ben frames it, is if we have the right lessons and the right virtual world and so forth, and things are set up correctly, then we probably should be able to get some sort of emergence out of something that when taken out of this virtual world and put in a completely different type of challenge, it should be able to use some of the things that it learned. And I'm calling this emergence because it's emerged the ability to do things in new places. It didn't have that before. It's emerged the ability to learn a new environment because it learned an old environment. And really, actually, normal emergence theory also is that consciousness is going to come out of this. For example, if we could somehow communicate with this thing, that it would we would discover that it came up with a sense of self, and that consciousness emerged. I mean, that's what we're talking about, emerging, not just really cool behaviors, but the actual idea of self and self-reflection and the ability to plan all these little things. So, for example, we think that some things are not emerged, can happen without emergence. Like, for example, we pretend that animals can do certain behaviors without consciousness, without memory, that we can just do it by knee-jerk reactionary things. For example, a fish or a shark is only just swimming towards blood and chewing on whatever is out there. It's not really thinking about it. He's just sort of pre-programmed like a killer robot that doesn't need any sense of self to be able to feed. He hasn't emerged in inner dialogue saying, hey, that looks tastier than that thing, or looks like that thing looks like it's going to kill me. This thing looks like I can eat it. So I'm going to go for the thing I can eat. Now, we feel like there's a bunch of sensors and neurons weighing the sizes of proportions that are somehow number crunching or prioritizing for him to swim after the smaller thing than the bigger thing, and that there's no conscious thought involved there, that would be too much for us to expect this killer robot shark. It's really tasty thing to be having. We would want to think that it actually was feeling a little bit of guilt or whatever about, eating that small creature over there. And it probably doesn't feel guilt, but actually, that'll be a fun topic later about animal guilt, because we found models of that, especially, because most animals are able to raise their young, and they have to put their young through and protect things and from other things, and so they have fear and so forth, but not consciousness, not a sense of self. It's not self-preservation that they're doing. They're not preserving their inner voice. They're not afraid of their inner voice shutting down. That's not why they're trying to not, why they're not, like, you throw them in water and they're trying not to drown. It's not because they're afraid their inner voice is going to cease. I mean, that's why I try not to drown, though also it hurts too, but and so I want to get back to the surface. But generally, most of the time, the reason I'm doing something wise and not dumb is because I'm terrified that I'm going to lose my sense of consciousness, my sense of self. I love these new sci-fi movies that are coming out. Not new, but like the 100, was it? It was where you could actually, I mean, this is all over, where you can upload your mind into a computer and then you could re-download it into a new body. So if you died, you would now be alive again. And would you be the same person? And then it gets into, well, would the soul follow that consciousness? Like, there's some beliefs that the soul would actually be in that data or whatever that was stored. But notwithstanding, I brought this up because because I don't think I would be comfortable with that. I think this movie called show called Upload, had this beautiful piece where whenever they do that to a brain, the entire head explodes right at the end, where they have to so you see this guy, this cute looking jock who gets into a car accident, and his girlfriend's father owns the upload company, and she wants him uploaded. And then they upload his brain to the computer, and then afterwards you see that they actually blow his head off in some way, where just smoke is coming off of where his head used to be. I'm not sure. Well, let's say this story happens in a couple places. Sometimes it has to be done because that's how much data they're extracting. Other times that's, in this show it was a joke. They were teasing the other shows about who, but definitely this person was not. So anyway, they upload the person into the virtual space, and when they do, they put he has all of his fears and anxieties and everything that he had while he was a conscious being, he doesn't want to die here either. And interestingly, when I feel that way, I feel it someplace in my gut and my mind. But I realize that thing that's making that feeling, and I'm hearing my inner voice telling me that, is probably very localized in my brain. Like I feel like all that can happen in maybe less than 15,000 neurons are actually being involved in this thought form. I don't feel like my whole massive brain is feeling it. Let's say. I'm going to try to elaborate on this a little bit so it makes sense, because it's part of like where the theory begins. Okay, actually, maybe I'll have to do it with a story here. So when I was pretty young and I was learning to wash my hands, it took all of my thinking to be able to move my hands in such a way that it looked exactly like so the person that was showing me to wash my hands, showing me what to do. So I moved them in a very mechanical, non-flowing way that made them. So I was doing is mimicking the picture that I could see. I could see how their hands move, so I made my hands move that way. But I wasn't feeling necessarily the cleansing motion going on. I wasn't creating any suction. I wasn't creating friction. In fact, I thought there was no friction. I didn't think his hands were actually touching, so my hands weren't touching while I was trying to do it. And then reached over and pushed my hands together and said, no, you got to wash your hands, push them together. And so anyway, the amount of mental bandwidth that was taking place was kind of like learning to play a piano or a guitar, tying your shoes. Probably should use tying my shoes as a better example. But point is that nowadays, I don't put that much mental thought into it. It's almost like pre-programmed for me. I have like something that does that. It's almost it moved from to what's the thing? Yeah, level 1, level 2 thinking. So it moved from level 2, where it was conscious of every movement, to almost a reactionary way of doing it. My mind immediately, actually everyone's mind, immediately, that we find that once we discover how to do something and not think about it, where we never have to think about it again, or we try never to think about it again. It's almost like we're also conserving energy, mental energy on something. We try to farm it off into something that is a level 1 thinking. So, and not level 2 thinking. Anything that's level 2 is needs to be moved to level 1 as quickly as possible, so we don't spend mental energy on it. That's just our way of doing things, and that's very a great idea. So like even driving a car now, when I get in my car, I'm not really driving. I'm just all just reactionary. I'm not paying attention to the road. I'm just listening to the radio, singing along with my song. And something, it's all reaction. Eyes, mirrors, hands, feet, pedal, speed limit, pacing other cars. Somebody swerves towards me, I swerve out of the way. All of that just happens on level 1. None of this requires any conscious thought. Somebody turns on their signal, puts on their brake. A guy waves me, and I go around him, and someone waves me by, a construction worker, because the lights are out, and they're fixing the lights, and all of that, doesn't even cross my mind. Like I'm just listening to my song on the radio, singing along, just doing these things, stopping, going, uh, waving at the dude. Okay, I actually connected with the dude for a second when I waved at him, but generally, no thought took place. Okay, now let's back up. That's bullshit. A lot of thought was taking place. In fact, I think like there was a full 16-year-old or 14-year-old kid driving me to work, and I'm this, 35-year-old dude taking a ride with this 14-year-old driving me to work, doing his very best, struggling like hell to not, flunk his driving test. I just don't have to sit there in his consciousness anymore. I think he's still thinking about everything that's going on, reacting. It's almost like I have a whole other consciousness inside of me that's not trying to like invade my mind. That just says, "Hey, dude, relax, listen to your radio show, sing along or whatever you're doing, and I'll drive you to work." I think that's more likely than a set of layer one reactions. I think I got this whole layer two thing going on that I'm not aware of what he's thinking or feeling. Actually, no, I can feel it when he gets hits the brake all of a sudden, and I have to like pay attention. I feel it in my gut too. I'm like, oh shit, I just dodged the bullet there. I think he feels that way too. I think we actually share a gut. I think that this 14-year-old and I have the same, some of the same memories. We share memories. We share emotions. I think he might have access to certain memories that I don't, but it's like I have access to the ones that he doesn't. Also, though, I think that even though I felt his anxiety, if he's actually thinking, I really don't want to drive to work today, I don't think I necessarily know. Like I wouldn't be able to judge his actual overall happiness level if he was actually another being. And also, the guy that ties my shoes in the morning, or the guy that washes my hands after I use the bathroom, I don't necessarily think is the same 14-year-old kid. I think it's actually like a 6-year-old that washes my hands now for me. And it might even be an 8-year-old that ties my shoes. I don't know that. And I think I might even be able to, if they just didn't involve hands, I think, like let's say what chewing gum or whatever, and one, the 14-year-old might be chewing gum, or the 13-year-old. I think could do that while the 6-year-old washes his hands. I think I could sit here and enjoy the sweet taste that's coming out of the gum. The guy on top, the guy who has control of my mouth right now. The guy that has control of my mouth and my eyes, well, at least I want to think I do. How much control over my body do I really, how many bodily systems do I want to monitor and make work for me? I don't think it's that many. I mean, if I have an itch to scratch, I want an arm to scratch it. But I think, so my executive self decides what parts are taking over. When are we going for a drive? When am I going to wash my hands and so forth? But this is sort of a turtle's exercise, because I'm saying, well, there's a me, there's a consciousness, and probably every other little bodily function I have has a little me with consciousness. That's probably convenient for me to think about. And so why I could say that, and I don't. So in other words, that gets put on the same list of theories that need to be, what are the pros and cons? How are these things convenient and allow me to not think anymore about other theories? and that's how I judge how long I should contain that theory. If it's so, I mean, I don't like that idea any better than I like the idea of emergence either. Oh, I don't dislike emergence. What I don't think would happen is I don't think I would emerge an executive by accident. And this is something that makes me interested in critical column theory. Thousand brain theory. Because it starts, I mean, in a way, what I'm talking about starts to sound like a thousand brains. But what actually, no, what I like about his theory is he doesn't actually ever, he's sort of anti-emergence in a way. He says we have these things and when I say anti-emergence, not emergence the way Ben talks about emergence. I agree with Ben's emergence things, okay, but where I differ, if we differ at all, is what are the starting point that emergence starts to happen. And so the emergence I'm talking about is that simplistic things gather together and make a complex behavior. I mean, we see that flocking behavior and so forth, but that doesn't mean any one of those birds are simplistic. They're very complex creatures, and they might be using knee-jerk reactions to make a simplistic decision about which way to go. But these are complicated beings. I guess what I'm trying to say is none of the arguments for like flocking behaviors and stuff or how they're used really resonate with me. I think they're correct, but I don't think they're correct in any of their use cases of what they support and what they don't. Where I'm going with that is, okay, emergence. I don't like Doug Lanatt's or maybe the Catholic Church's idea of emergence is where I'm going, is that once you get to a certain thing, something special happens. And when I say Catholic Church, it's because the Catholic Church, the way they rewrote evolutionary theory, not because evolutionary theory, according to Darwin, is much different than what we believe evolutionary theory is now, because he took some concessions with the church, I believe, to say, okay, yes, these animals don't have language, they don't have creativity, and these things are things that have to they're set, human beings are separate in certain ways. And that sounds very species-ish, but if you looked at some of his early like racist writings where he talks about people in certain parts of the world of not actually even thinking, they don't even actually have thought. He also talks about ants having thought. Like he wrote this paper I read where he was describing two ants from the same colony where one had been gone a while, came back, and the other ant sees him. And this is, scientific writing, where he believes the first ant doesn't recognize the second ant. Once he does, he apologizes for being rude initially, and then there's like a forgiveness phase of the relationship, and they go back happily ever after into the ant hill. And Darwin actually thinks this is going on with these animals. So in other words, what I'm saying is he doesn't believe necessarily that consciousness is something unique to humans. However, the church wanted Darwin to think to frame it as unique to humans. And so what we have is we have Darwin today, but the church indoctrinated version of on the psychological level, and then we have Darwin on the non-psychological level, which was less filtered by the church. They could accept that we have the same monkey body that a primate has. And they didn't have to alter that. They just had to alter the fact that you didn't have to actually preach to the monkey and send him to heaven. You didn't have to set out, you didn't have to go and learn monkey and preach to the monkeys and preach to the birds and the different species. Because had we actually accepted Darwin's theory of evolution, we would, if the church had, it would have had to do that. And so there was a compromise made that the church could accept. I'm not saying they accepted Darwin evolution. I'm saying that evolution had at least not attacked the salvation that they didn't want to have to also save animals. And so it falls short of doing that. However, if you read Darwin's actual work, it wouldn't fall short, is where I'm going. Okay. But the idea now is that self-reflection, the ability to have moral decision making, is something that's specific to man, to humans only, and the animals wouldn't be following this sort of moral decision making. They wouldn't be weighing good versus bad or pain versus pleasure. Or the idea that by foregoing pleasure now, they can plan to have something better in the future. So by walking this long distance to the watering hole, they can actually have a delicious drink. They wouldn't be planning ahead. They'd just be reacting to the environment, like, oh, I smell water this direction, therefore I must walk that direction, or that was the direction that everyone walked. They must be doing something. No, it never even gets that far. It's just complete reactionary. No set of weighing facts or remembering anything would be needed. And of course, we know this is not true. I mean, even bees have a memory, and they come back and they do their little dance, and everyone sees that, know that bee is reliable or unreliable with its dance. And they even, if you want to look up those bee experiments where the guy had put, where the beekeeper had put the gull in the middle of the river on a little raft, let some bees discover it, and then have them go back to the hive. Those bees came back to the hive, explained where they saw the food, and the other bees didn't believe them because they know that was the middle of the river. And then they had other situations where they did get believed because the food was someplace rational. And so the bees that were watching the communications from the other bees were able to know what they were talking about and create a mental picture of the world that they had from their own memory, and said, oh no, that can't be, or that can be. And then some of them actually decided to listen to or not listen to the scout bees based off of their lack of credibility. So they have like a credibility score with these other bees. And anyway, the amount of processing it takes to do all that doesn't look like it would happen if you looked at the number of neurons in these bees. I think there's only 38,000 neurons, right? Oh, 38,000 neurons definitely wouldn't be able to do this, but I mean, it would take billions or millions or something, right? Actually, interestingly, is I wonder if we could actually create a bee mind out of something like ChatGPT's language model size. I don't know that we actually could. Interesting, right? Could we make something as intelligent as a bee using OpenAI's ChatGPT? I don't actually think we have it. So what it is we know that a biological neuron is far more capable than a neural net neuron. Neural net neurons carry one or two floating points, whereas as a biological neuron, like found in a bee, is much more complex. So we don't really quite have a one-to-one comparison between a neural net neuron and a biological neuron. You know that. But I'm wondering if someone could come up with some numbers for me that it would take a back propagating neural net to come up with the mind of a bee, or even like say a spider capable of building a spider web. I actually think the mind of a spider, spiders don't have to do as much mental work as a bee. So also, so anyway, we have these different scales of that the animal's body even lets it participate in. For example, a slug only has to crawl around and find food and doesn't have to fly around, has to have some memory, has to have some concept of time, and so forth. Anyway, the number of concepts required to keep alive as a slug might be different than a bee or an ant or a human, So we might sometimes think that the neural hardwiring of a slug is only powerful enough to do slug-like activities, or a bee is only for bee-like activities. But if we look at the number of neurons in a slug versus a slug might have 300 or 400 times more neurons in his brain than a bee does. And yet the task in which they had to evolve, that they evolved these neurons, are quite different. And I guess what I'm saying is there's no correlation between how intelligent something has to be and how intelligent something is to survive. And that's sort of disconcerting when we talk about the scaling and emergence and free energy and all that. So in other words, maybe the slug is really doing some complex mental fantasies that are beyond what the bee is doing within his own small scope of his smaller world that he exists in than the bee. Whereas a bee doesn't have any time for that, just basically just barely running on fumes, just like their bodies are barely designed to be able to do what their bodies do. So they run on deficit. Maybe anyway, so I just wanted to bring that up because I feel like that will be, I want to use that later to explain some other things in this theory. So what was next on the topic was that I might be running out of steam. That's what it is. Okay. Okay. So some of the things that we do as people that we think are special for people, Darwin thought animals did. I'm not thinking that Darwin was really very insightful in the mental world, even though Darwin thought that most of his evolutionary theory, the parts that we grasp, are really quite simple or almost common sense, and we shouldn't make a big deal out of them. What he was excited about was the rest of science, the things that what we're learning was more interesting than evolution. And so when I read his non-evolutionary stuff, I'm fascinated and encourage everyone to do that. Maybe I'll try to come up with some suggestions at the end of this. But okay, so there was also a particular movement at that time of Darwin where we were trying to discover the minds of animals, discover how animals were thinking. And there was some heresy going on because a lot of people thought animals really thought like us, and Darwin wasn't any different. Now we don't believe that. We have a completely opposite belief, supposedly, or I mean, as a scientific community, these animals are innocent of thinking until they can prove to us that they're thinking. Whereas maybe back then we before the church got so involved. It was animals were thinking unless we can prove that they weren't. So, for example, I think somebody was going to exterminate a bunch of pigeons or rats in some city, so they had a court. They called the court. They summoned the pigeons, and the pigeons didn't appear in court to defend themselves, and so they were slaughtered. But the idea was if these pigeons were intelligent, they would show up and defend themselves, and they didn't. And that wasn't too weird. That was acceptable in our society, especially when we wanted to slaughter pigeons. Especially, yeah, when we wanted to slaughter the pigeons, we would accept these type of things, whatever's convenient, you know. Right now, it's more convenient to think pigeons aren't intelligent, or that they're whatever is more convenient. Science usually doesn't necessarily follow the truth. It follows what we want it to. In some cases, it's opposed to what we want. You know, like global warming or whatever. So where I'm going with that is that, yeah, I feel like any theory that's trying to marginalize some group, whether it be pigeons or make another group more special, whether they be humans, I think has to be looked at with a grain of salt. And it doesn't mean that, the motivation behind emergence is so that we can actually get work done. I'm talking about like AI work, that we must be doing the right thing, even though right now doesn't look like it's working. It will start to work once we get to a certain threshold. So it means we don't have to change what we're doing. I'm not saying what we're doing is wrong, of course, but I'm saying that it is kind of convenient. So, okay, I want to go from the other point of view is if I had programmed something that was completely capable of walking around in pits with bridges and land, that was pre-programmed to do that, and I was to write this in a rule-based system, and I did this with like about 5 or 6 rules about how to navigate. Like, you know, when you're getting near a pit and it looks like where you want to go is on the other side, try to find a bridge and go over the bridge, you know. And then I was to try to program the low-level parts to actually navigate like that. That would mean that we'd have to have agreed upon waypoints. The higher level consciousness and the lower level sensory environment would have to sort of agree upon certain points of movement. So like it couldn't be 100% the higher level. I guess what I'm saying is this rule system, this general rule system I was about to concoct, needs waypoints, and that's going to get that from a lower level system. Okay, so we would say that one or the other. So let's look at the program that we write for both of those. One of them is one that says whenever I see a difference on the 2D plane, I'm going to put a little point there. I'm going to put an XY coordinate there. So I'm going to have this little loop that actually we can't really have a loop. It gives us, doesn't matter anyway, but we're going to have a thing that scans around us as it moves. So we're going to drive this thing like a tank. We're going to have primitive actions of move forward 1 meter, rotate 45 degrees left or right, go back 1 meter. And so that's going to be its driving ability. Its sensory ability will be look ahead, and every time you see a change in the environment, in the terrain, like say we have green grass to pit, we're going to put a little GP there. Whenever we see a green grass to bridge, we're going to put GB there, so forth. And so we're going to have this thing scan And we're going to make it, before it goes forward, most of the time 1 meter, at least scan 2 meters ahead and record what's 2 meters ahead. So that way it doesn't fall into a pit. So anyway, why I'm going to do this is this shows what I think would be called like the minimal level of what this is going to take. And we're going to compare that. We're going to compare that program to a neural net program that's also able to do the same thing. And we're going to look at how much data each one takes up. We're also going to look at two other aspects. One is we're going to make that first program I'm talking about, the one that does left right, we're going to make it have to learn from its mistakes. And then we're going to also do this with the neural net program. It's going to have to learn from its mistakes. And we're going to watch how quickly they learn. And we're going to find that the first program, which is very similar to something that Patrick and Peter would write, learns it much quicker than the other program, than the neural net program. And we're going to think, though, somehow, I don't know, I'm not really going to think it, but some people might, that the neural net program's doing it a little bit closer to how humans do it. But I'm going to actually think I'm doing it closer to how Pat and Peter's anyway. Like this is level 1, level 2, bottom up, top down. So that some of that's important to consider. Oh, actually, interestingly, I want to go on the direction of Ben's direction. I want to take the Pat Peter version, or the version that is sort of driving it around, and see if we can get emergence of consciousness out of this. Any better as emergence of consciousness out of the other neural net one. I have a feeling that the challenge is the same. Don't think. Oh, okay. So why I say this is, it doesn't matter how many little lifter uppers to make this easier to learn that you have. Consciousness doesn't emerge by accident there. I mean, that's might be a long jump for me to try to make that deduction now, but what I'm saying is whatever I have to do to get consciousness to emerge out of those two systems, I don't think it's going to be any different. I don't think one's any more likely to emerge one than the other. I think the neural net is not, see, some people would want to say the neural net because it's more fuzzy, has more it's more cryptic. Whatever it has to do because of the free energy principle of if it, see, like, because it has to induce all the same rules that our other program was pre-programmed with. But I also can take that other program and take those rules out and make it learn on its own using a simpler system that's closer to the neural net, that actually uses stochastic reasoning, similar to something that PLN or would use. And it's going to have the same sort of induction going on, the same Solomonoff even. And that doesn't make it any more likely to emerge anything newer than the other one. Oh, and I'm not saying that neither one will emerge anything at all. I'm not discounting that possibility. I'm just saying that I don't think one is any more likely to than the other. So I don't see an advantage. I don't see all the advantages or disadvantages. However, somehow there's this religious gut feeling that some people have that the neural net will somehow have an advantage that this good old-fashioned AI stochastic program doesn't have. I don't know where that belief comes from, other than some sort of a misplaced religious banking on emergence. And that's kind of a piece of what makes me a doubter. So yeah, that, and the fact that people have a gut feeling that the neural net would. Bothers me that they might be banking on something that doesn't make sense. Oh, well, they are, there's something about it that's magical or mystical, maybe because they called it a neural net and not good old-fashioned AI. So I'm saying that neither one of them has an advantage. However, we can restructure the first program to have new structures, and we don't quite know how to restructure the neural net. Maybe we do, maybe we don't. But so anyway, if you guys can come up with ways of restructuring the neural net program to be more likely to do better than it's doing, that would be great. Um, add an LLM to it, whatever. But let's take the first program and add some structures to it where we're going to keep a score of how well the rules are doing and what should it been paying attention to and not paying attention to in that world. For example, we add a noisy part of the terrain where it's just dirt instead of brass. Does it form an opinion about dirt? Well, it will. Both programs, by the way, have to learn through carrot stick. You might say that every time the program falls and fails, that it takes some of the things that it thought were a good idea and changes that. We could actually even have a variable called how much of a good idea was this, how much attention should we pay to it, and all these stochastic variables can be added onto things. And also we can encode all that into the prediction algorithm, actually. A lot easier. For example, if you try to move into a pit and you fall, you can predict the fall. So we don't actually have the thing fall into the pit. We might just make it painful. Like, in other words, like, you get injures itself for a moment, but always bounces back to where it was. So we don't have to have the catastrophe or whatever. What I say is that, and then we don't even actually have to have that happen. We just need to have the ability to imagine it happening or run that simulation within itself. And it might even be easier if it could run that simulation without its physical body getting involved. And so as we talk about doing this, we do this with neural net too, but let's talk about the physical structures that we're going to add to the program to make that happen. And we're actually going to add those through a series of rules. For example, before we go 1 meter forward, we're going to experience 1 meter forward. And so in other words, we could have a rule that A is pre-experience. If the experience was good enough, keep going. Anyway, so what I want to do is write in meta the actual heuristic, anyway, some of the stuff there that goes there. The imaginary program that I'm talking about. So then we can talk about it in our next discussion a little bit. And then, because I feel like there's a certain meta program with 1T that is about experimentation that creatures do. Really where I wanted to go with this, though, is if it did work, it would be that what if something was born already with that experimental structure set up in it? That would be a lot better than being born without that. I mean, learning would happen a lot quicker if we already had the ability to imagine. And I can't, okay, so sure, that obviously is true. would a spider be able to build a web without the ability to imagine? Maybe that's just where I wanted to go. So this is like a whole different chapter, but I think maybe I should start writing it now. What would it take what would be the minimal programming it would take to build a spider web with a minimal amount of, actually, how much imagination does it take a spider to build a web? And I think quite a bit. I think with a little bit of or just even a little bit of imagination, with that small bit of imagination, it makes a spider able to build a web. Without it, it would be nearly impossible to come up with enough reactions and neural wiring to make something adapt the web to the environment. I don't think there's any prescriptive method that takes no intelligence. For example, you can solve certain mazes by putting your hand against one wall, walking, and that didn't take much intelligence. You'll still get intelligence, and you'll still have certain types of mazes. And same with a spider. You can't just do this one action. You can't button mash, build web, build web, build web, build web, and have it come out the way I did with the hand on the side of the maze. Walk forward, walk forward, walk forward, keep hand on wall, whatever. I think the spider is going to have to use some imagination. He's going to have to look at an area and see where that web is going to be, and then mechanically try to recreate what his imagination sees. And in little tiny chunks, like he doesn't have, once the big picture is there of the web, he only has to do the grunt work now. What I'm saying is, okay, if you have to run a tie line from A to B, you have to do that, but it doesn't matter what the rest of the web is going to look like at the end. Once you've picked out the A to B task, then you stand back and the A to B is done. Okay, where is that? Oh, yeah, the imagined web, that's that part. Okay, now let's do the next part, and so forth. I think is a lot easier than trying to pre-program something to reactionarily build a web anywhere. So in other words, spider is going to have to look at an area and imagine the web there, and then try to build what he imagines. That's easy, or much easier than trying to actually, than any other form of trying to build a web, right? I think it is. Can someone tell me an easier way of doing that for a spider, or for any creature, even for a human? You know, I don't think, something that would use less mental resources. I don't think that there is. Anyway, so I almost think that nature kept it simple and gave everything, every bug, every bee, an imagination, and then they're constantly comparing the world to their imaginary world and trying to get those things in sync. And that's what makes them capable of beaver building a dam, birds capable of mating. Everything starts with an imagining of themselves doing something, and then them following through what they imagine themselves doing, and comparing the context of them doing it, going, this doesn't look like what I imagined, and try to make it look closer to what they imagined it to look like. And I think every animal instinct, everything that they do is based on doing that. That's kind of one of my theories, is that the minimum level of the minimum thing for a spider to even operate is the ability to imagine his environment a certain way, and the ability to feel that it's not the way he imagined, and the urgency to make it the way he imagined. Um, and that solves a lot of animal intelligence problems that we have. And I've taken this theory way further than just that thought, and I'd love to explain it at a different time. So why, and, and so anything that doesn't, if a neural net, so in other words, and I think the neural net would need that. Any animal, that's the lowest. I'm saying like the smallest turtle is that, just that. And that you don't build that out of turtles. You can't do that with turtles. An LLM is similar in that it predicts what's going to come out. It sort of says this is what should be next. Oh, that wasn't next. So this other thing must be next. Oh, yep, it was. This one. Oh, but now it's different. And it just sort of falls along and tries to get it right. And I think we can do that with imagination structures as well, because that's what we're doing. We have, like, I'm looking at a brick wall right now, and I can see how perfectly aligned all the bricks are. Oh, except that one, so a little bit off. And that kind of, okay, but the rest of the brick wall is perfect except for that one brick. Now I'm okay with, I can picture that brick wall the way it is. But when I first looked at it, I imagined it was way more regular until I saw that. And so at that point in my mind, the construction avatar prototype was a perfect brick wall that really only took as much energy as it did to have perfectly aligned bricks mentally, which we all can easily. Then I say one brick's a little bit not aligned, and you can handle that. Now it takes up twice as much space in our brain, but it hasn't, didn't change to the proportion. Okay, so the neuron way would say that one brick out of all 50 bricks or 500 bricks was only 1/500th. And so in other words, in mental space that the neurologically would take up would somehow be proportional. At least if I was a spider looking at that wall, maybe might be proportional neurologically. I don't think that. I don't think it, but I think that lots of people do think that the actual visual cortex, the information coming out into the spider eyes, are actually recorded within its brain somehow, or encoded past V1. They think V5 and V1 are the same thing for a spider. And I don't think that's true. I think they're very different. I think V5 is taking up two elements of the brick wall, just like it took up with mine at V5. Maybe at V1, it took up 500. And when the brick was messed up, it still took up 500. But now at V5, it went from taking 1 to 2. And I think that's true for the spider as well. And I think in order to do that, to have that meta level, requires a little bit of conservation of energy, which, with Tristan actually, would agree with Song. So, I mean, that V5's job is to organize V1 in such a way that it's not a mess anymore. And he thinks that, and so in other words, like it's a way of saying, oh yeah, you'll get that for free. Don't worry about building 5 layers to the visual cortex. They'll automatically emerge for you. And I just, that's the part I don't believe. And this is why some people say this sounds like intelligent design, because the system is actually set up to work already in all these beings and bees and people and all of that. And they all look exactly the same, and they use the same design. And so maybe that design came from someplace. No, I don't think it did. What happened was there was something one time in nature that worked, and that was the only thing that ever replicated. And um, and that's why it's the only species we see on Earth, is the species called the uh, multicellular organism. I mean, what I'm trying to say is the organisms with a nervous system were the only system. Well, even plants have a nervous system, but what I'm trying to say is if there was some other better design out there, uh, it's certainly not happening on Earth. So in other words, we see this mono design happening everywhere, or we might find three classes of design if we were really to look harder and see that the particular type of paramecium is totally on the outskirts, on the outside of our evolution. Or something like we might see that we're related to the immortal jellyfish and the lobster, but we're not related to this other thing, this thing that they had on the newest Star Trek, Teratote. Okay, so where I'm going with that is that this like DNA thing that was a really brilliant thing that happened that worked. And so all these species with eyeballs tend to have optic nerves that send information to something that reacts. And we don't find many species with an optic nerve that goes nowhere. I mean, that's important, but and if we do, we will find remnants of other parts that go nowhere, because this is a thing that now doesn't use never had somehow selective breeding had made it not need those other parts, or even not even need the optic nerve, but the optic nerve is still there in wait for when something does need it later. And so, for example, that's what the immortal jellyfish has, like a bunch of body parts that'll never grow. But if they were in the different species, they would. That's why we supposedly have something like DNA similarities. Like if it really needed to grow a pig's heart, we could grow a pig's heart out of an immortal jellyfish DNA somehow, let's say. Exaggeration or not. The part I'm going for is that, all these parts are they only work one way. The eye, the ear, the nose, whether you're a spider, your brain works exactly like the human brain and reacts the same way on the same psychedelics that the human brain works on. So something that makes you a little bit, speeds you up, amphetamines given to a spider will make them a little bit more like a human on amphetamines when they build their web. Give them some LSD or some pot, they'll start acting like a human, or on pot and LSD, building a spider web. Something about our operating system reacts the same way to these same hallucinogens and so forth and stimulants. So I'm kind of saying that the software is very similar in our brains. Probably their imagination is also very similar, and we've seen that. We've done tests where when we give them drugs that make them hallucinate a little bit, they hallucinate a little bit. Point is that their executive on down system is exactly the same design as the humans. It's not that we've emerged something special on top. No, if we're looking for the smallest viable AGI that we could build, instead of building a human, we could build an ant. Some people would have a hard time believing an ant is AGI, but I get that. It sounds, I almost believe you when you say that. But I'm looking at the difference between what a human learns in life and what certain animals learn in life. What I'm trying to say is I don't know that you can train your dog to do arithmetic, but I do know you can train a human to do arithmetic. But I don't know that if you never trained the human to do arithmetic, that the human wouldn't be doing arithmetic anyway. That's what I'm trying to say is that I don't know that we ever learn anything that we think we learn. I know that we have schools and we teach people things, and I know that before I was taught something, I didn't know it. So I do believe in learning. I do believe it's happening, but not to the extent um, that I think others think that it's happening. I think that what's happening is people are giving me enough clues that resonate with something that's already almost there that I can start to use these new tools that they're giving me when I'm learning something. Uh, and you're probably wondering, well, you mean the computer was a tool that your brain was ready to use 1,000 years ago? All someone had to do was hand it to a guy 1,000 years ago, and he could have used it. I'm like, yeah, definitely. I don't think that's what you meant to ask. I think you meant to ask, when I was 6 years old, could I use a computer? At what point in my life was I able to use a computer in such a way? Uh, I think what you did when you built the computer is you designed it in such a way that I could use it. You designed it for my brain. My brain didn't design itself for your computer. I think this programming system that you created for the computer was based off of something that you kind of already knew how to do first. And then you gave me this computer, and then I learned to do what you did, what you were expecting me to do with it. I don't think the sky's the limit on what I'm going to do with it, my own imagination. And it's quite extraordinary. I might even be able to affect other people's lives and do all sorts of wonderful things with it. But I don't know that I'm special as a species. Oh, I guess, okay, let's do this for a dog here. A dog may not know how to ride a horse. They never were born. A dog will never think about jumping on a horse's back and riding it ever. Let's say, just hypothetical, right? And then one day you've got your corgi and you set him on the back of a horse. Now he has a great time. Now every time he gets a chance, he wants to ride on horseback. Would you think you wouldn't say that he learned anything, would you? And I feel like that's me in the computer. Okay. The fact that a human created a computer for me to get on to ride on was really cool. And that shouldn't be overlooked. But I'm trying to compare it to the corgi. And I think it's an apt comparison. So like animals know how to ride on other animals. Cats, you give them that thing that's a disc that vacuums your floor. They love to ride that, right? But they may not have ever done that before. But something is you've taken something that they could almost already do and gave them the ability to do it. And so I feel like maybe some of the things that we do are only that exciting because our minds are capable of so much. We are so much that we don't even grasp. We don't even know. Just like the dog doesn't know he ever could have ridden on the back of a horse. And if he experimented a little bit and did, which some do, and they do, and they will get that. And in fact, there's several animals that have an impulse to ride other animals, to ride on other animals. And that's like a natural thing that they're born with. And it might be, this be weird if it was a natural thing for us to build things that conform to, that were simplistic to see. For example, if two people were asked to build a shelter and taken out into nature, one person might build a grass mound with a hole in it and crawl under it, and that's a shelter. Someone else might find some things and make a square structure. And the fact that, but more likely, most people will build a square structure because it's simpler to imagine. And or like, a door. Most doors are square. We don't have very many round doors around us. And part of that is industrialization. And some of it's just mentally simpler to have it's a lot easier to build a door frame and a door that are the same shape. And it's a lot easier to have a 4-sided shape. And we could have a 3-sided, but that's harder to measure and transport and requires angles and all that. So the point is that sometimes we do things because they're mentally easier to grok, and our imagination is more likely to keep things regular, at least now. This is a weird tangent, but it does belong in the book. It just doesn't belong in the lecture part. Let's see here. So where I'm going is that we tend to build things and imagine things are easier to imagine than hard to imagine. Because imagination does take a little bit of work. So we have to reproduce it. There's a certain, actually there really is a really important point in this I'm not going to make because it's really big. But I'll give the short story that might make the point. That, I mean, it's one that I've noticed quite a bit, is if I drive past a billboard every single day and it's got a phone number, it's for some insurance company, and I can see the numbers it's something like 7676. I saw repetitive numbers. I don't remember what the first part was. Let's say there was 1-800. The first 3 numbers I've never actually looked at, but I've looked at, I think the last numbers were 7676. There might have been a 7 or a 6 in the first part of the number. But anyway, I don't think that you could hypnotize me right now and make me regress through my life and figure out what those first 3 numbers were. I don't think they're anywhere in my memory. I think the only only thing that's in my memory are things that I looked at and remember looking at. That I consciously looked at that number and said, oh, 283, that was the same as my grandmother's prefix, or, had to use some sort of memory technique on those first 3 numbers to retain them. They are not encoded anywhere in my neurons in any sort of visual, memory, like anywhere. They are only there if I consciously made something up to put them there. And that's weird, because sounds very anti-emergence. Well, and I don't think the way things would have worked out, I don't think that's the way the system would have emerged. I think I would have started out with something that actually saw the world rather than from bottom up rather than top down. No, the only way I see something is when I go through the process of comparing it to experience or comparing it to something I can do easily. And it took conscious choice. I have to create a story about everything I see. Otherwise, I don't remember seeing it. Or I have to give it a name. For example, I drove past a gravel road and noticed a lot in the gravel. There were leaves. I can't tell you how many leaves were there, but I can tell you it was a gravel road with leaves. If you're to say what color was the gravel, I could kind of say gray and bluish gray, sort of gravelly looking, what gravel looks like. And then so you're off picturing the last gravel road that you saw, which wasn't gray. It was more like white gravel. Where you're from, they don't make gray gravel. It's all white gravel. So your exemplar and my exemplar are different, but they still take up the same amount of space in our brain and our language. That said, if I have leaves on my gravel, I don't actually create a gravel with leaves. I create gravel and then I cover it with leaves in my imagination. And that's what I remember. And I don't remember actually the picture. I just remember the thoughts that created the gravel in my mind, and I made sure that the gravel I was looking at and what was in my mind weren't too far off. At least, and actually they were far off, and I added leaves. So that's how it. But it started out as gravel, just like the brick wall started out perfectly aligned until there was one brick that wasn't. And so the world is built, at least in my head, through a generative process. My senses are only come in through a generative process, at least after a certain age. So whatever took the environment and made it generatable was kind of like the thing that washes my hands for me or ties my shoes. It creates in my mind a picture that I can compare to the real world. And actually, I don't even bother anymore. I just accept whatever picture that they show me, whatever mental picture, and that's what I see. That's what I'm looking at all around me. It's not a picture that I created, a picture that some other being created for me, because I certainly didn't do all the work to get it there. But I know it was work to get it there. I know that it took something to recognize the door as a door. I didn't expend the energy, but something did. Something realized it was a door, not a square refrigerator. It made a bunch of mental effort at that and put it there for me as a refrigerator or door for me. And it was generated. The simulation that I'm looking at all around me, my sensory world, is a simulation built by potentially intelligent beings inside my head. Things that were able to, but we don't have to call them intelligent. We don't have to call them conscious right now. But I know that whatever I am, the thing that's talking to you, didn't do all that work to get that there. But I know I also can't dismiss it as no work at all was done. I mean, no, I did no work at all, but I can't dismiss it as if my senses just automatically did that for me. I'm going to have to say my brain automatically did that for me. Somewhere between V1 and V4, or actually between V1 and V5, something did some real mental arithmetic to make sure that was the right object that was presented to V5. I don't think that thing, I think that thing almost has to be near AGI to be able to do what it's doing, and so forth, all the way to V3. So also the same thing. Okay, so now let's go to the eye of the spider. I think the same thing for him. That somewhere between V1 and V5 was an AGI that created that for him. A general intelligence that was able to sort of collate all the information that's received and say, you know what, that's that's water dripping down that wall. That's not an actual rope that you can climb up. That's a stream of water. And that's what a spider's AGI might tell them, is that this particular thing you're looking at is a predator. A general intelligence is required to be able to learn what predators are, or to be able to classify it that way and convince the spider that that's what he's looking at. I don't actually know for sure the thing talking to you right now is a general intelligence, but I know everything supporting me is. And all I have to do is sort of button mash and basically steal their ideas. I mean, out of my head, out of these other intelligent beings that are thinking for me. I have this thing that's automatically constructing the speech for you. And I feel like I secretly might just be trying to take credit for it. And I don't know who it is or what it is. that's doing it, and I'm okay with that. I mean, okay, I can claim all this, the entire thing inside my skull is me. If someone's going to reward it, I want the reward to come to me, to outside my head, and you're not gonna know which part of me made that, right? But my point is that you're that I don't know that the thing that's actually consciousness is experiencing consciousness right now is as intelligent as it thinks it is. I think it might actually be uh, commandeering ideas, just because maybe it's a little bit of my. I don't mean your ideas. I'm talking about ideas coming out of my head, because I don't feel as intelligent as. It's not just about feelings, but I don't have that. I'm not. I just know things are always worse than they seem. I Okay. Here's the thing. I drove safely to work today. I don't know if I personally deserve credit for doing that. I mean, the thing that's talking to you. I think the 14-year-old boy that drove me to work deserves credit for that. But I don't know where he is in my head. He's somewhere. He's the guy that drove me. So, um, and it's not the person talking to you. I can guarantee you. So that's what I'm saying is I'm always commandeering some part of my mental apparatus. And I don't know if other people feel this way. I mean, I sometimes I always feel this way. I can sort of what I do is I look at how much energy I put into something and compare it to how much energy I used to have to put into it. And if it's any different, I don't expect that I got better. I just expect that became less conscientious of the energy expended. And I've done some experiments to actually confirm that that the amount of energy expended is exactly the same. And it will be fun to talk about those experiments. There's so much to talk about. It just stressed me that the amount of mental energy that it takes to tie my shoes is no different than it was 10 years ago. It was very different when I was 6. It took a lot of mental energy. But once I was able to do it, it never got cheaper. I didn't suddenly become better at it. That 6-year-old still takes exactly so many, uses up exactly the same number of neurotransmitters to tie my shoe today as it did, let's say, 20 years ago. So, if my brain was the same brain that emerges things, I think it would have actually gotten a little bit better in the last 20 years and uses less neurotransmitters. That's kind of one of my sticking points that make me against emergence. Because it wouldn't be a process that just suddenly stopped and froze. Oh, yeah, that brings me to one of my most seriously intriguing problems that I have with emergence is that the way instinct works, there's 2 theories of instinct that I have or I've heard, one that I have and one that I've heard. One theory is that instinct is a set of reactions that something has that um, that makes them very similar to others in their species with those same reactions, right? So, put in the same situation, instinct will drive them to do the same sorts of things. Okay, and that's done under a certain way. Now, learning and action. When I say learning, I mean like when a dog learns a new trick to how to do something, he does it sort of out of memory. Like he memorizes how to shake your hand, and you memorize, how to lift his paw up and have it shook, right? Now, he remembers to do that when you reach your hand out. And so his mental rule is you lift your hand up, he lifts his hand up, right? Okay, that's done in a certain mental apparatus. And instinct's done in its own apparatus. Two different apparatuses mentally. I don't know that Mother Nature would do something that way. In other words, what I'm really trying to say is that, oh yeah, I don't think these two systems would be much different. But yet, right now, scientists believe the systems are completely diametrically opposed. They believe instinct is a set of reactions that are unlearned, whereas learned reactions are learned reactions, and they operate from a different point of view. One of them is born with, one of it learns. I have a feeling they're both learned. Even instincts are learned. I think, okay, the reason why this is unless you can propose to me a system that's capable of instinct and also systems capable of learning, and tell me how they're different or tell me how they're the same, I'm going to sit around confused. But I've come up with a system of how learning works. And I think scientists have as well. And I think instinct needs to follow that same system. The only difference is that learned happens before they're born. In other words, they're both using the same learned post-reactive reactive learning system, except one is learned before it's born. That I'm okay with that sort of a theory. Or I'm even okay with you having a learning system that reuses the instinctual part of the animal. But why would Mother Nature pick two? I don't see a reason. I don't think anyone sees a reason. But yet everyone's theory requires there to be a reason because it requires it to exist. So that's another part of neural theory that makes sense, that I don't see as could ever be accurate or correct. In other words, whatever system one system uses is the other. And if they can't come up, and since they can't quite point out a system that uses either for me, I've come up with a system that does both. That's easily scientifically explainable. And that is the system I talked about before, where they imagine themselves doing something, and then they just try to follow the dance script or the imagination, their own imagining themselves doing it. So it starts out with for example, imagining you're walking from here to there, and then you just walk from here to there. You can all try this at home. And it works. It doesn't matter if you're 2 years old, the moment you learn how to walk, you can imagine yourself walking and then you walk there. And it doesn't take any more mental power than that, at least in your consciousness. And I don't believe in the animal's consciousness it takes any more than that either. Also, it doesn't take any less. I know it sounds like a hand wave, but it's not. I can also walk you through the building of that system here in a few minutes if you want. But the point is that it starts out with what we call the mirror cells, where monkey see, monkey do, where they see somebody doing something, and they imagine they see themselves as doing it as well, and body is already constructing how they do it. So they see you wave, and they're already, at the moment they saw you waving, they already had formed the neural pathways to wave themselves. There's a bunch of cells that are in charge of doing that. Basically being able to dance in a rhythmic way with other people, or dancing in step with other people. And we love to do it because it feels good. It's natural. Monkeys like to do it. Actually, many animals like it, I'm sure. It's a pleasure. It brings us kind of pleasure. It's instinctual to be able to copy what we're seeing um, and so and anyway, a few years ago they discovered mirror cells in people. And now they've discovered them in bonobo apes, and now they've discovered them in dogs. They haven't discovered them in cats yet, but I'm sure they will in a couple of years. But anyway, I think every animal has them, even spiders, believe it or not. Any animal that is capable of mimicking or following along. I watched cats practicing with their mirror cells. Like I had raised a bunch of cats, and they all were playing follow the leader, and one of them would have to jump from here to there. So the next one would get there and jump from here to there. But I could tell every once in a while, one of the people in line didn't know that they were going to have to jump there, and they watched the cat in front of them do that. And so anyway, they were watching each other, figuring out how the other cats were doing what they were doing and trying to follow along and go through the same path. And some of them had more competence than others. But you could see that before they did that, they didn't know what they were going to do until they saw the other cat do it. In other words, that's how follow the leader works, right? you do what you see the other guy do. And that's just part of instinctual playing that all, I think many species do. They have follow the leader type games because it's just part of programming or how we self-program. So, yeah, I feel like that's the minimum software one of the minimum software requirements. Gosh, I'm definitely not going to let anyone listen to this. It definitely needs to be in written form. So it becomes as technical as it needs to be. Okay, so next part of the book is that follow the leader is this minimal operating system. Okay, why don't we like this? How come I sense this hesitation for myself and everyone that, no, this is too much, Douglas. See, nothing is at that level except dogs, cats, and humans, and spiders aren't at that level. Ants aren't at that level. They're much simpler creatures. I don't know why you think that. I don't know why I think that. I feel like it's more gut defense than it is science that makes me not want to accept that. Also, it's just years of having that like beat out of me by myself and others. I've resisted that for this line of thought for so long. I have so many ways that help me avoid this line of thought, but it doesn't seem natural. I shouldn't be throwing up this much resistance. Usually if you have a bad idea, your mind will throw up resistance, right? But that's not what this is. This is more like a existential fear that tries to keep me from this line of thinking. That the minimal viable animal, we would call it, MVA, instead of MVP, or actually they call it MVI, minimal viable intelligence. Okay, how about minimal viable animal? Would actually have an imagination. A paramecium, in order to hunt for food, would have to have an imagination. The problem is all of our experimentation and tests all show that they do. I mean, this is why I don't have. This is why I can't reject this idea. Every experiment and every scientific test that we ever perform always proves that they do. We just can't find it, so we just throw away the data. But or we laugh and we think it's interesting, but we don't actually accept any of the data that we collect that tells us this. And every time we try to collect data that doesn't tell us this, it won't. All of the data tells us that every animal, including even bacteria, have the ability to somehow do some prediction into the future. But they show some behavior that is looking to react to things that have not yet come. Also, and the only viable way that they could be doing that is to somehow have an internal mental model that is somewhat, say, sensory to what is to come, or some way of encoding, this is what's to come, this is how I'm going to react to it. Be it like basically also the ability to learn, to know what to avoid. And sometimes this happens on a really larger scale genetically, but sometimes we find it on a less macro scale, on the individual scales. Anyway, whatever scale we're testing it on, we always find it. So how come we don't accept it scientifically, our findings? Or how come we don't have a theory that would support our findings yet? And that's what bothers me. That's why I have this theory that I do. I feel like, of course, I need to go into all the details and prove to you what I'm saying is true, and I probably should. It's just not right this second. Let's do that on a different chapter. But I can promise you, for all the research I've done, this is true. That whether that be bees, spiders, slime molds, whatever, they seem to have emerged some sort of prediction ability. Well, and sometimes when I say prediction ability, I just even mean the ability to change the behavior, their next behaviors based off of information rather than sensory data. For example, those bees. Sure, it goes back to that they learned that there was a river there. There was sensory data there, but to encode that much data without having a middle level V5 thought process just wouldn't be possible. The physics of only having those, what I say, 25,000 neurons just wouldn't support this sort of mental activity. Had it been bottom up or sensory at that point, if it was V1 data. So anyway, so like their behavior, and the fact that we can also predict their behavior, that we can set up an experiment and have them react in such a way that shows that they're processing information. If we were to set up an experiment and find something not processing information, that we probably wouldn't be that interested in. So, of course, most of these experiments are to show that things are doing information processing. Even slime mold maze solving is showing us something. Now, some people look at this as a and make a assertion and go, see, it doesn't take any intelligence, and you can have this emerged maze solver, right? But let's take the same slime mold and put it in a smaller situation, and it's still able to do, it's still doing things that would take an imagination to do, or an imagination could do. I'm not saying all these things will require an imagination, but they could easily be solved, or they could be solved a lot easier than any other explanation we have with the imagination layer, with a V5 layer or a V4 layer. I'm sorry. V4 might call it the imagination. The difference between V4 and V5 in my mind is V4. Actually, yeah, this is important. Okay. V4 is actually what the world is saying V5 should be. V5 is what you're pushing back with in your mind. Things that should be solved on V4 would be like if you're looking at something and you can't, and you're trying to figure out what it is, V4 will give you enough hints that you can form a V5. And when you stop looking at it, V4 is gone, but V5 is still there. So the only thing you're ever seeing is V5. Okay, if I'm wrong about all these Vs, just shoot me, but it's okay. I mean, I'm going to be consistent with Lee wrong. And so you can map those into whatever correct places they should be, okay? What I'm saying is, what I'm pretending here is that V5 is what we project on the world, and V4 is what the world's trying to project onto us. And so, you're hallucinating when V4 isn't showing you a picture that V5 is. You know that you're making up in your own mind. But if you're actually looking at it, V4 and V5 are in agreement, and so it's a much stronger deduction. And so that's what I'm doing with that. So what I'm saying is most of what the slime mold is doing is in V5 and not V4. Oh, that actually, here's what I could say is we can do experiments that would deduce whether something was physically, visually, information was being fed to it right at that moment, or was that information buffered from and used later? If it's buffered and used later, that's why I'm calling it an imagination layer. In other words, like, it closes its eyes and still is reacting to what it thinks is going to happen. And I'm saying that almost all of our tests with every animal seems to allow that. They seem to be able to do that, even slime mold. They're able to look at something, a picture that's not presently on their neural, feeding their nerves, just like a bacteria is able to communicate using the same, in the same ways that dendrites communicate. And then they're reacting to those communications, and whether they are experiencing those reactions in the same way a dendrite is very likely. I mean, I think it is. So they could be processing information in the same way that a neuron does. And actually, there's new theories that believe very particularly that our brains evolved from a bacteria. Bacterial spores have become nerve cells. And the communication system that nerves use are the same that bacteria use, which was really a cool thing. However, it also meant that certain toxins that were toxic to bacteria are also toxic to our neurology. And of course, we don't mess with those, but they do exist. And they exist, like, say, in spiders and certain amphibians and reptiles and fish produce some of these neurotoxins that have like long-term damage, but they also have other potential, even antibacterial potential, once we learn how to adjust those toxins. What I'm saying is there's a whole new class of antibiotics. We used to call them, there's a word for it. And we used to grow things out of mushrooms that were antibiotic. And it wasn't just like there's like a whole bunch of even psychoactive useful things that have nothing to do with mushrooms or psilocybin. But the way we manufacture, we have the synthetic versions, and we usually have a spore version that we make. And interestingly, we will someday have an amphibian or a reptilian version of these same things that we make. Is where all that was about. Okay, we'll move that.